Good morning, students. So now I am doing class per class 12 science. The topic is continuity of a function. So in the last online class we did some problems on this chapter, continuity of a function. So today we'll do more problems on this chapter. Okay, so this is from exercise 2a. Each question carries 4 marks. Page number is 256, right? So हामीले लास्ट अनलाइन क्लासमा पनि यो कन्टिन्युटी अफ ए फंक्शन को हामी कतिवटा प्रब्लम्स गर्दै थियौं। त आज हामी त्यही नै कन्टिन्यू गर्ने छौं। त एक्सरसाइज कुन चाहिँ हो भन्दा पनि एक्सरसाइज 2a इच क्वेशन क्यारीज 4 मार्क्स। पेज नम्बर इज 256 फ्रम योर बुक हायर मैथमेटिक्स of class 12 by SND. Okay, the question is question number 3, that is each question carries 4 marks section. Question number 3 मा के छ भन्दा फेरि a function f of x is defined as follows, right? त यहाँ function f of x is defined as follows. त यसलाई कसरी डिफाइन गरेको छ भन्दा फेरि f of x is equal to 3 plus 2x हुँदैछ कति बेला for minus 3 by 2 less than or equal to x is strictly less than 0. If x lies within minus 3 by 2 and 0, the value of f of x is 3 plus 2x. And f of x is equal to 3 minus 2x if 0 less than or equal to x less than 3 by 2. So this is x is equal to 0 also is here. And x is strictly less than 3 by 2. This is x greater than or equal to 0, but x is less than 3 by 2. Then we have f of x is equal to 3 minus 2x. Okay? And then next, f of x is equal to minus 3 minus 2x. What is the condition given out here? For x greater than or equal to 3 by 2. So if we have x greater than or equal to 3 by 2, then you can write f of x is equal to minus 3 minus 2x. Now we have to show that the function f of x is continuous at x is equal to 0, but you have to show that the function f of x is discontinuous at x is equal to 3 by 2. So let us do the first part now. You have to show that the function f of x is continuous at x is equal to 0. That means you have to find out the right hand limit at x is equal to 0, left hand limit at x is equal to 0, and the value of the function when x exactly equal to 0. If all these three are equal, then it is continuous, otherwise it is discontinuous, right? So let us check at x is equal to 0. Okay, so for x is equal to 0 point, right? So let us write down for right hand limit. For right hand limit, so what do we write? For x is equal to 0, how will you write? Limit x tends to 0 plus. Limit x tends to 0 plus means x is tending towards 0 from the right hand side. Okay, then write down f of x is equal to limit x tends to 0 plus. What is the meaning of x tends to 0 plus? On the right hand side of x is equal to 0, all the values of x are greater than 0. Now in this case, what is the value for f of x when x greater than 0? So here x tends to 0 plus ले चाहिँ के बुझाउँछ? x चाहिँ कतातिर अप्रोच हुँदैछ? 0 तिर अप्रोच हुँदैछ from which side? From the right hand side. अनि यो x is equal to 0 को राइट पट्टि जति पनि x को भ्यालु हुन्छ सबै ग्रेटर देन 0 हुन्छ। त x tends to 0 प्लस भनेको नै x ग्रेटर देन 0 पनि हो। त x ग्रेटर देन 0 हुँदाखेरि व्हाट इज द भ्यालु फर f of x? यहाँ कहाँ छ x ग्रेटर देन 0? यसमा छ हैन? x ग्रेटर देन 0 हुँदाखेरि 3 minus 2x, राइट? सो x ग्रेटर देन 0 हुँदाखेरि के भयो? 3 minus 2x. So here you should write 3 minus 2x. Now since x is approaching towards 0 from the right hand side, here in this case you can put the value of x as 0. So which is equal to 3 minus 2 into 0, which is equal to 3. So what is the right hand limit? It is 3 only, right? Now let us write down for left hand limit. For left hand limit, so for left hand limit, how will you write left hand limit? You know that it is limit x tends to 0 minus f of x is equal to limit x tends to 0 minus. So what is meant by x tends to 0 minus? x is approaching towards 0 from which side? From the left hand side. And on the left hand side of x is equal to 0, all the values of x are less than 0. So x tends to 0 minus means x less than 0. So what is the value for f of x when x less than 0 in this case? When x is less than 0. X less than 0 is here. So if x is less than 0, then f of x is equal to 3 plus 2x. So here you can write 3 plus 2x. Is that clear now? So now x is tending towards 0 from the left hand side. Okay, that is x is approaching towards 0. You can take the value of x as 0 out here. So is equal to 3 plus 2 into 0, which is equal to 3. That means we got the left hand limit as 3. Is that clear? Now what will you do next? We have found out right hand limit, we have found out left hand limit. So you have to get the value of the function f of x when x exactly equal to 0. Now here you should write at x is equal to 0. So is your question ma x is equal to 0 kaha cha? X is equal to 0 is out here. When x is equal to 0, what is the value for f of x? It is 3 minus 2x, right? So at x exactly equal to 0, then what is the value for f of x? It is 3 minus 2x. So here you can write f of x is equal to 3 minus 2x. So here you can put x exactly equal to 0. So therefore f of 0 is equal to 3 minus 2 into 0, which is equal to 3. That means all these values are equal, isn't it? That is right hand limit is equal to 3, left hand limit is also 3, and the value of the function at x is equal to 0, that is f of 0 is also 3. So all these three are equal. That means the function f of x is continuous at x is equal to 0. So here you write limit x tends to 0 plus f of x is equal to limit x tends to 0 minus f of x is equal to f of 0. So all these three are equal. That means you can write hence the function f of x, hence the function f of x is continuous at x is equal to 0. Proved. So hence the function f of x is continuous at x is equal to 0. So I think you have understood it. So you can copy it. This is the first part of this question. We have shown that the function f of x is continuous at x is equal to 0. So you first copy it. Now we'll do the next part. That is, we have to prove that the function f of x is discontinuous at x is equal to 3 by 2. Okay, so copy it. Now we'll do the next question. So now we'll do the next question, that is you have to prove that the function f of x is discontinuous. The function f of x is discontinuous at x is equal to 3 by 2. Now for x is equal to 3 by 2. Let us check whether the function f of x is discontinuous or continuous at x is equal to 3 by 2. But in this case, you have to prove that the function f of x is discontinuous at x is equal to 3 by 2, right? So let us write, so for x is equal to 3 by 2, let us write for right hand limit. For right hand limit, what do we write? Limit x tends to, we are checking at x is equal to 3 by 2. So I will write it here, 3 by 2 plus f of x, which is equal to limit x tends to 3 by 2 plus. So what is the meaning of x tends to 3 by 2 plus? That is, x is approaching towards 3 by 2 from the right hand side, and on the right hand side of x is equal to 3 by 2, all the values of x are greater than 3 by 2. So what is the value for f of x when x greater than 3 by 2? This is here, x greater than 3 by 2, f of x equal to minus 3 minus 2x. So it is minus 3 minus 2x. Is that clear to all of you? Because in the question it is given that when x is greater than 3 by 2, f of x is equal to minus 3 minus 2x. Is that clear? Now you can put the value of x as 3 by 2 in this case, because x is approaching towards 3 by 2 from the right hand side. Okay, so is equal to minus 3 minus 2 into what is x here? 3 by 2. Here 2 gets cancels. So minus 3 minus 3 is equal to what is here? It is minus 6. So we got the right hand limit as minus 6. Okay. Now we have to find out the left hand limit. So for left hand limit, what do we write? Limit x tends to 3 by 2 minus, because we are checking the discontinuity of the function at x is equal to 3 by 2. So limit x tends to 3 by 2 minus, then what do we write here? F of x is equal to limit x tends to 3 by 2 minus. So what is the meaning of x tends to 3 by 2 minus? X is approaching towards 3 by 2 from the left hand side, and all the values of x on the left of x is equal to 3 by 2 are less than 3 by 2. So what is the value for f of x when x less than 3 by 2? Where is x less than 3 by 2 out here? X less than 3 by 2 is here. If x is less than 3 by 2, what is the value for f of x? It is 3 minus 2x. So here you should write 3 minus 2x, which is equal to, now you can put x is equal to 3 by 2 out here. So 3 minus 2 into 3 by 2. Here 2 gets cancels, right? So it is 3 minus 3, which is equal to 0, right? So in this case, we see that this right hand limit not equal to left hand limit. So the function f of x is discontinuous at x is equal to 3 by 2. So in this case, no need of finding out the value of f of 3 by 2 or the value for f of x when x exactly equal to 3 by 2. Is that clear? So यसमा चाहिँ हामी f of 3 by 2 को भ्यालु निकालिरहनु पर्दैन, किनभने राइट ह्यान्ड लिमिट नट इक्वल टु लेफ्ट ह्यान्ड लिमिट आइगयो. द्याट मिन्स हामीले डाइरेक्टली के लेख्न सक्छौं? द फंक्शन f of x is discontinuous at x is equal to 3 by 2, right? So write down. So you write since limit x tends to 3 by 2 plus f of x, that is your right hand limit, not equal to limit x tends to 3 by 2 minus f of x. किनभने यो दुईटा त इक्वल आएन नि त, त्यही कारणले गर्दा यो फंक्शन के भयो? डिस्कन्टिन्युअस भइगयो. According to the definition of discontinuity, so from here you can write down that therefore the function f of x is discontinuous at x is equal to 3 by 2. So it is proved. So therefore the function f of x is discontinuous at x is equal to 3 by 2, because in this case we got right hand limit not equal to left hand limit. So I think you have understood it. You can copy it. We'll do the next question now. So now we'll do the next question, that is question number 4. So this is important question, question number 4. Given that f of x is equal to 1 minus cos x upon x square when x not equal to 0, and f of x is equal to 1 when x exactly equal to 0. You have to show that this function f of x is discontinuous at x is equal to 0. Okay? त यसमा चाहिँ हामीले के प्रुभ गर्नुपर्छ भन्दाखेरि जुन चाहिँ यहाँ गिवन फंक्शन छ गिवन f of x it is discontinuous at x is equal to 0, right? So what is the question out here? What is the given function of x? That is f of x is equal to 1 minus cos x upon x square when x not equal to 0. त यसमा अब हामी बुझ्नु पर्छ x not equal to 0 भनेपछि के हो? त x not equal to 0 भनेको either x is greater than 0 or x less than 0, right? X greater than 0 or x less than 0. So x not equal to 0, x not equal to 0 को meaning चाहिँ के हो भन्दाखेरि x is either greater than 0 or less than 0. Okay? So let us write here given f of x is equal to 1 minus cos x upon x square when x is greater than 0 and x is less than 0. Is that clear now? Now you know that a right hand limit at x is equal to 0. You have to check the continuity or discontinuity of the function f of x at x is equal to 0. And also it is given that x is greater than 0 and x is less than 0. x not equal to 0 को meaning हो either x is greater than 0 or x is less than 0. Okay? The right hand limit को लागि हामी x greater than 0 use गर्छौं on the right side. X tending to 0 plus means x is approaching towards 0 from the right hand side, and on the right hand side all the values of x are greater than 0. And for x less than 0, x tends to 0 minus, right? X is approaching towards 0 from the left hand side, and on the left of x is equal to 0 all the values of x are less than 0. Is that clear? So for both the right hand limit and the left hand limit, we are using the same function f of x is equal to 1 minus cos x upon x square. So यसमा हामीले separate left hand limit र right hand limit निकाल्यो भने सेम नै आउँछ त्यसको भ्यालु. Right hand limit जति आउँछ left hand limit पनि त्यति नै आउँछ हैन, किनभने we are using the same function. Is that clear? So when x is greater than 0, we are using this function. When x is less than 0, we are using the same function. So in this case, no need of getting the separate right hand limit and left hand limit. Is that clear? त यसमा हामीले separate right hand limit र left hand limit निकाल्नु जरुरी छैन, किनभने x greater than 0 मा पनि अनि x less than 0 मा पनि हामीले यही same function नै हामी use गर्छौं. त in that case, just find out limit x tends to 0. The limit x tends to 0 भनेको either x is approaching towards 0 from the right hand side or from the left hand side. Is that clear? So in this case, don't find out the separate right hand limit and left hand limit, just find out limit x tends to 0. So it indicates that x is approaching towards 0 from the left hand side or from the right hand side. Is that clear? So let us find out limit x tends to 0 f of x. You just find out limit x tends to 0 f of x. Okay? So which is equal to limit x tends to 0. What is the value for f of x here? F of x is this one, 1 minus cos x whole divided by x square. Is that clear now? So let us simplify it now. So you know 1 minus cos x. You did in trigonometry in class 11 in submultiple angle. What is the formula for 1 minus cos x? You know this formula, isn't it? That is 1 minus cos x is equal to, this is 2 sin square x by 2. You know this formula. 1 minus cos x is equal to कति रहेछ? 2 sin square x by 2 अनि 1 plus cos x पनि छ. 1 plus cos x चाहिँ के हो? 2 cos square x by 2. तर हामीलाई यहाँ के चाहियो? 1 minus cos x चाहिएको छ. So which is equal to limit x tends to 0, right? So what is the formula for 1 minus cos x? It is 2 sin square x by 2 divided by x square. त अब हामी यहाँ के मेथड युज गर्छौं भन्दाखेरि लिमिटमा गरेको पाराले गर्ने यो. Sin square x by 2 भनेको you can write sin x by 2 two times. हामी sin x by 2 यहाँ दुई पल्ट लेख्न सक्छौं. x square पनि हामी दुई पल्ट लेख्न सक्छौं. That is x into x. Is that clear? So which is equal to, now this 2 is constant which is free from x, so you can write it outside limit. So 2 into limit x tends to 0. ठीक छ. अब sin square x by 2 भनेको दुई पल्ट लेख्न सक्छ हैन, जस्तै a square भनेको a into a, so likewise sin square x by 2 is sin x by 2 into sin x by 2. So let us write here, it is sin x by 2 into sin x by 2 divided by, similarly x square can be written as x into x. Now you know the standard form of sin, that is limit x tends to 0, sin x upon x is always 1. You know that, isn't it? That is limit x tends to 0, sin x by x is equal to 1. So these are the formula, right? So you should convert this expression into the form sin x by x form, right? So let us separate it. So is equal to 2 into limit x tends to 0, sin x by 2 upon x. So below sin x by 2, one of these x is written out here. Now what is the other expression? That is sin x by 2 divided by x. Is that clear? So I think you have understood it. Now in this case you should convert into the form of sin x by x form. But instead of x, what is here? X by 2. त यसलाई पनि हामी के बनाउँछौं? x by 2. हामी आफै लेख्दैछौं x by 2. ठीक छ? फेरि यहाँ पनि sin x भने के छ यहाँ? x by 2. त यसलाई पनि हामी के बनाउँछौं? x by 2. त हामीले यहाँ के थप्यौ त डिनोमिनेटरमा? That is 1/4 is written out here. Ourselves, we are writing ourselves 1/4 in the denominator, but it should be cancelled. So you should write here into 1 upon 4. Is that clear? This 4 should be cancelled in the denominator. So that's why you have to write into 1 upon 4. So here, हामीले denominator मा half into half थप्दैछौं. Half into half भनेको 1/4 थप्यो denominator मा. तर त्यसलाई क्यान्सल गर्नलाई हामी न्युमरेटर मा के लेख्छौं? Into 1 upon 4. Is that clear? So if you cancel all this, you'll get the same expression out here. So it's correct, right? So 1/4 is constant, you know that. This 1/4 is constant, so it should be taken outside limit. Okay, so let us write down which is equal to 2 into 1/4. 1/4 is constant, it is taken outside limit. Now wherever there is x, you have to write down the limit. That is limit x tends to 0. This is your sin x by 2 upon x by 2 into for this second expression also you can write down the limit because it contains x. So limit x tends to 0. This is sin x by 2 divided by x by 2. So I think you have understood it. Okay. Now this is the standard limit whose value is 1, right? So 2 1s are 2, 2 2s are 4. So this is half into 1 into 1, which is equal to half. That means we got the value of the limit, that is limit x tends to 0, f of x is equal to half. That is both right hand limit is equal to left hand limit is equal to 1 upon 2. Okay. Now you should find out the value for f of x when x exactly equal to 0. Now let us write here at x is equal to 0. So at x is equal to 0. At x exactly equal to 0, what is the value for f of x? It is 1. Therefore, you should write here f of x is equal to what? 1. In the question, it is given that when x is equal to 0, f of x is equal to 1. So, what is the value for x out here? It is 0. That is f of 0 is equal to 1. So, are these two equal? No. That is limit x tends to 0, f of x not equal to f of 0. That means it is discontinuous. Okay. यदि यो पनि हाफ आको भए चाहिँ के हुने थियो? दुईटा इक्वल हुने थियो, कन्टिन्युअस भइहाल्ने थियो. तर दुईटा इक्वल आएन. त दुईटा इक्वल नआएको कारणले गर्दा चाहिँ यो के भयो? डिसकन्टिन्युअस भइगयो. त यहाँ के लेख्छौं हामी? सिन्स लिमिट x tends to 0, f of x not equal to f of 0. यो दुईटा इक्वल आएन. त इक्वल आएनको मतलब के हो? The function f of x is discontinuous at x is equal to 0. Therefore, the function the function f of x is discontinuous at x is equal to 0. So it is proved. So I think you have understood it. So you can copy it. We'll do the next question. Now we'll do question number 5. For what value of f of 4 the function f of x is equal to x square minus 16 divided by x minus 4 is continuous at x is equal to 4. So you have to find out the value for f of 4. That means you have to find out the value for f of x when x exactly equal to 4. So that this function f of x is equal to x square minus 16 divided by x minus 4 is continuous at x is equal to 4. Is that clear? Is the question clear to all of you? You have to find out the value for f of 4. That means you have to find out the value for f of x when x is equal to 4 such that the given function f of x is equal to x square minus 16 divided by x minus 4 is continuous at x is equal to 4. Is that clear to all of you? So let us do the solution now. So what is the given function here? That is f of x is equal to x square minus 16 divided by x minus 4. Right? So when you put x is equal to 4 here, what do we get? 4 square is 16, 16 minus 16, 0. 4 minus 4 is 0. 0 by 0 is undefined. Undefined means it is discontinuous at x is equal to 4. But in the question, it is you are asked to find out the value for f of x when x exactly equal to 4 such that the given function is continuous. Okay? But in this case, if you put x is equal to 4 exactly, this function f of x is undefined. Right? If x is equal to 4, then f of 4 is equal to 16 minus 16 divided by 4 minus 4, which is equal to 0 by 0. This is known as indeterminate form. 0 by 0 is indeterminate form. I told you about this one also. Or it is undefined. Or you can write it as undefined. That means undefined means this is the definition of discontinuity. That is the function f of x is discontinuous at x is equal to 4. Right? But what should be the value for f of 4 such that the function f of x is continuous at x is equal to 4? That means this function of x is defined when x not equal to 4, isn't it? Therefore, the function f of x is equal to x square minus 16 divided by x minus 4 is defined when x not equal to 4, right? त्यसो भए यो 4 मा मात्रै अनडिफाइन हुँदैछ नि त। तर x not equal to 4 अरु भ्यालुज x is equal to 4 बाहेक अरु भ्यालुहरु हाले भने चाहिँ यो के हुन्छ? डिफाइन हुन्छ। x is equal to 4 मा मात्रै अनडिफाइन हो। तर अरु भ्यालुजहरु हामी x को अरु भ्यालु हाले भने चाहिँ यो फंक्सन के हुन्छ? डिफाइन हुँदैछ। That means the function f of x is equal to x square minus 16 by x minus 4 is defined when x not equal to 4. So when x not equal to 4 means either x is greater than 4 and x is less than 4. Now I think you have understood it. So this function of x is defined when x is greater than 4 and x less than 4. So in this case also no need of getting the separate right hand limit and left hand limit, because for both these inequality, that is for x greater than 4 and for x less than 4, we are using the same function of x, that is x square minus 16 divided by x minus 4. Is that clear? So let us find out only limit x tends to 4. No need of getting limit x tends to 4 plus and limit x tends to 4 minus, because in this case for both right hand limit and left hand limit we are using the same function, that is f of x is equal to x square minus 16 divided by x minus 4, right? So here you can just write down limit x tends to 4 f of x. Let us find out the value of this function. So let us find out the limit of this function, okay? So is equal to limit x tends to 4. Maneko, x is approaching towards 0 from the right hand side or from the left hand side, but x exactly not equal to 4, isn't it? So what is f of x here? It is x square minus 16 divided by x minus 4, right? So let us factorize the numerator. You know how to factorize the numerator. Limit x tends to 4. What is x square minus 16? It is x plus 4 into x minus 4 divided by x minus 4. Here x minus 4 gets cancels. So which is equal to limit x tends to 4. This is your only x plus 4, right? Now you can put x is equal to 4 here. So x is approaching towards 4 means you can put the value for x as 4. So which is equal to 4 plus 4 is equal to 8. That is, 8 is not the exact value of this limit, but 8 is the limiting value of this function f of x. So 8 is not the exact value of this function x, okay, but 8 is the limiting value of this function, okay. So for both right hand limit, both are included out here. Both right hand limit and left hand limit are included in this limit, okay. Now what should be the value for f of 4 now, so that it is continuous at x is equal to 4? So therefore at x is equal to 4, f of x should be equal to 8 also, isn't it? Because right hand limit is your left hand limit is equal to 8. So the value for f of x should be 8. So you put x is equal to 4. What is f of 4 now? So f of 4 is equal to 8. So what should be the value for f of 4? It should be 8, so that the given function f of x is continuous at x is equal to 4. So this is the answer. So what is the value for f of 4? It is 8, such that the given function is continuous at x is equal to 4. Is that clear? So this question is very, very important, right? So you can copy it. We'll do the next question now. Now let's do question number 6. It is similar to question number 5, right? The function f of x is equal to x square minus 1 upon x cube minus 1 is undefined at x is equal to 1. Obviously, at x is equal to 1, this function f of x is defined. If you put x is equal to 1 out here, 1 square minus 1, 1 minus 1 is 0. 1 cube is 1, 1 minus 1 is 0. That is 0 by 0 is always undefined, isn't it? So at x is equal to 1, this function f of x is undefined. So when is this function defined then? If x not equal to 1. If x is not equal to 1, then only this function f of x is defined. The x not equal to 1 means either x is greater than 1 or x is less than 1. Okay. So for both these expression, that is x greater than 1 and x less than 1, we are using the same function f of x is equal to x square minus 1 divided by x cube minus 1. Is that clear? Next, what should be the value for f of 1 such that f of x may be continuous at x is equal to 1? The तिमीले यहाँ के निकाल्नु पर्छ? You have to get the value for f of 1 such that f of x may be continuous at x is equal to 1. So is the question clear to all of you? So I think you have understood it. Now let us do the solution. Let's do the solution now. The function f of x is equal to x square minus 1 upon x cube minus 1 is defined when x not equal to 1. So what is the meaning of x not equal to 1? Either x greater than 1 or x less than 1. कि त x greater than 1 हुनु पर्यो कि त x less than 1 हुनु पर्यो हैन त राइट ह्यान्ड लिमिट भनेको x greater than 1 मा आइपुग्छ अनि लेफ्ट ह्यान्ड लिमिट भनेको x less than 1 मा हुन्छ So in this case also no need of getting the separate right hand limit and left hand limit, just find out limit x tends to 1. The limit x tends to 1 को meaning चाहिँ के हो भन्दा फेरि अघि पनि मैले भने x tends to 1 भनेको either x is approaching towards 1 from the left hand side or from the right hand side. Okay? So let us find out limit x tends to 1 f of x, right? So let us find out its value is equal to limit x tends to 1. What is the value for f of x in this case? It is x square minus 1 divided by x cube minus 1. Is that clear? So we can factorize it, right? So let us factorize it. Limit x tends to 1. This is your limit, right? So limit x tends to 1. So x square minus 1 भनेको a square minus b square, x whole square minus 1 whole square divided by, in the denominator also, this is your a cube minus b cube. What is a whole cube? X whole cube minus 1 whole cube, right? So you know the formula. I think you know this formula. A square minus b square, a plus b into a minus b. Let us write down the formula. Limit x tends to 1. So what is the formula here? X plus 1 into x minus 1 divided by, in the denominator, this is your a cube minus b cube. What is the formula? A cube minus b cube? A minus b into a square plus ab plus b square. What is a square? X square plus, what is ab? X into 1 is x plus 1, right? So here in this case x minus 1 will be cancelled. So which is equal to limit x tends to 1. So this is your x plus 1 divided by x square plus x plus 1. I think you have understood it. Now you can put x is equal to 1 here. X is approaching towards 1 from the left hand side or from the right hand side. That means it is approaching towards 1, right? So we can put x is equal to 1 in this case. So 1 plus 1 divided by, what is 1 square? 1 plus 1 plus 1, which is equal to, this is your 2 by 3. So I think you have understood it. Both right hand limit and left hand limit are included out here. So what is this value? It is 2 by 3. Now what is to be determined? What should be the value for f of 1 such that f of x may be continuous at x is equal to 1? So you f of 1 ko value कति भयो भने चाहिँ the function f of x is continuous at x is equal to 1 भनेर भन्दैछ यहाँ. त f of 1 को भ्यालु पनि कति हुनु पर्यो? यही हुनु पर्यो. किनभने right hand limit should be equal to left hand limit is equal to f of 1. Since right hand limit is left hand limit is 2 by 3, so f of 1 should be 2 by 3. So let us write here. So at x is equal to 1, therefore f of x should be equal to, this one is also 2 by 3. So you can put x is equal to 1 here. So f of 1 is equal to कति हुनु पर्यो? That is 2 by 3. The f of 1 पनि right hand limit र left hand limit को बराबर हुनु पर्यो. That is equal to 2 by 3 हुनु पर्यो, such that f of 1 is equal to 2 by 3, so that the function f of x is may be continuous at x is equal to 1. So what is the value for f of 1? It is 2 by 3. So this is your answer. So is that understood? So you can copy it. We'll do the next question now. Now let's do this question number 8. The function f of x is equal to 1 upon x, and within third bracket log of 1 plus 3x minus log of 1 plus 2x is undefined at x is equal to 0. The function of x is given as this expression, so it is undefined at x is equal to 0. So if you put x is equal to 0 in this case, if you put x is equal to 0 here, log 1 is 0, and this is also, if you put x equal to 0, log 1 is 0, 0 minus 0 is 0, 0 by 0 is undefined. So this function is defined when x not equal to 0, isn't it? So if x not equal to 0, then only this function of x is defined. The x is equal to 0 means undefined bhayego. ठीक छ? So what value must be assigned to f of 0 if f of x is to be continuous at x is equal to 0? That means what should be the value for f of 0 if f of x is to be continuous at x is equal to 0? Okay. Now from the first part we can write down that the given function f of x is defined when x not equal to 0. So let us do the solution now. The function f of x is equal to 1 upon x within third bracket. What is given here? Log of 1 plus 3x minus log of 1 plus 2x is defined at x not equal to 0. So what is the meaning of x not equal to 0? You know that x is greater than 0 and x less than 0. So for x greater than 0 we are using the same function f of x is equal to this one. For also x less than 0 we are using the same function f of x is equal to this one. Okay. So in this case also no need of getting the separate right hand limit as well as left hand limit. Is that clear to all of you? Just find out limit x tends to 0. X greater than 0 भनेको right hand limit मा आउँछ, x less than 0 भनेको left hand limit मा आउँछ. त दुईटै कन्डिसन को लागि हामी सेम फंक्सन युज गर्छौं. त्यही कारणले गर्दा हामीले सेपरेट राइट ह्यान्ड लिमिट र लेफ्ट ह्यान्ड लिमिट, सेपरेट राइट ह्यान्ड लिमिट र लेफ्ट ह्यान्ड लिमिट निकाल्न पर्दैन. You just have to find out limit x tends to 0 f of x, right? So therefore limit x tends to 0 f of x, right? So limit x tends to 0 f of x. Okay, so which is equal to limit x tends to 0. What is f of x out here? 1 upon x within third bracket, it is log of 1 plus 3x minus log of, this is your 1 plus 2x. Is that clear? Now multiply by 1 by x out there, and you can separate the limit also, isn't it? So you can separate the limit out here. So which is equal to limit x tends to 0 log of 1 plus 3x divided by x, right? What is the second term? Minus limit x tends to 0 log of 1 plus 2x divided by x. So I think you have understood it. Now what will you do here? You have to convert into standard limit form. You know the standard limit form. Limit x tends to 0 log of 1 plus x divided by x should be there. So instead of x, what is here? 3x. That is, this x should be multiplied by 3 to convert into a standard form. You know a standard form, isn't it? That is, let us write it out here. Limit x tends to 0 log of 1 plus x divided by x is always 1. You know this standard limit, isn't it? If the base is not written out there, it is understood that the base there is e. If the base is not written there, it is understood that the base is e, right? That is log of 1 plus x, base e is there. Here also the base is e, there also the base is e. So instead of x, what is there? 3x. This x should also be multiplied by 3. But in this case, what is the value for x here? It is 2x. So again, this x should be multiplied by 2 to convert it into standard limit form. So which is equal to limit x tends to 0. This is your log of 1 plus 3x divided by, let us multiply it by 3. So it is 3x. तर हामी आफै मल्टिप्लाई गर्दैछौं 3 ले. तो त्यो 3 लाई क्यान्सल गर्नु हो भने चाहिँ यहाँ इन्टु के लेखिन्छ? 3. Is that clear? Similarly, for the second term, minus limit x tends to 0 log of 1 plus 2x divided by, this x should also be multiplied by 2x to convert it into a standard form. So it is 2x into, this is 2. Is that clear? Now what will you do here? That is into 3. 3 is constant, take it outside limit. This 2 is also constant, take it outside this second limit. Okay, so which is equal to 3 into limit x tends to 0, right? So it is log of 1 plus 3x divided by 3x. Next, minus 2 into limit x tends to 0. This is your log of 1 plus 2x divided by 2x. So I think you have understood it. So let us evaluate it now. You can evaluate the limit. You can find out the value of this limit, right? So which is equal to 3 into, what is the value of this standard limit? That is your 1 minus 2 into, that is also 1, isn't it? What is the value of this limit? That is 1, right? Is it understood? So which is equal to 3 ones are 3 minus 2, which is equal to 1. So both right hand limit as well as both right hand limit and left hand limit are included in this limit. So both are 1. Okay. Now in this case, what is to be determined? What value must be assigned to f of 0? What value must be assigned to f of 0 if f of x is to be continuous at x is equal to 0, right? So at x is equal to 0, f of x should be equal to 1, right? Or what is the value for f of x here? It is 0. That is f of 0 should be equal to 1. Okay? So f of x को भ्यालु चाहिँ कति, f of 0 को भ्यालु चाहिँ कति हुनुपर्ने रहेछ? f of 0 को भ्यालु पनि 1 नै हुनुपर्छ, अनि मात्रै the function f of x is continuous at x is equal to 0. So is it clear to all of you? So you can copy it. We'll do the next question now. So now we'll do the next question, that is exercise 2a. Each question carries 5 marks. Page number is 256. Now question number 2 is, let f of x is equal to x square by 2 when 0 less than or equal to x less than 1. So when 0 less than or equal to x less than 1, then f of x is equal to x square by 2. And what is the value for f of x when 1 less than or equal to x less than or equal to 2? It is 2x square minus 3x plus 3 by 2. Now we have to discuss the continuity of f of x in the interval 0 less than or equal to x less than or equal to 2. So let us discuss the continuity of f of x in the interval 0 less than or equal to x less than or equal to 2. So what is the meaning of continuity in the interval 0 less than or equal to x less than or equal to 2? That means you have to prove that this function f of x is continuous in between 0 and 2. That is, in between 0 and 2, the function f of x is continuous, including this 0 and 2. That is, in between 0 and 2, whatever may be the values in between 0 and 2, the function f of x is continuous. So you have to prove that the function f of x is continuous at every point in the interval in between 0 and 2, including this 0 and 2. Okay? So discuss the continuity of f of x in the interval 0 less than or equal to x less than or equal to 2. Okay? Now again, I am explaining you this question. F of x is equal to x square by 2 when 0 less than or equal to x less than 1. And f of x equal to x square minus 3x plus 3 by 2 when 1 less than or equal to x less than or equal to 2. You have to discuss the continuity of f of x in the interval 0 less than or equal to x less than or equal to 2. Now in this case, you have to check the continuity at every point in the interval in between 0 and 2, including this 0 and 2 also. So you have to include 0 and 2 also. This is known as closed interval, because in this case x is equal to 0 is also included out here and x is equal to 2 is also included out here. So this is known as what? Closed interval. So in this closed interval, you have to prove that this function f of x is continuous. That is, the function f of x is continuous at every point in the interval in between 0 and 2, including 0 and including 2 also. Okay? So let us find out that, let us check the continuity at x is equal to 0 and on the right of x is equal to 0. So in this case, you cannot check the continuity of the function on the left of x is equal to 0 because it is given that x is greater than 0. Okay. Now for x is equal to 0. Now let us write down at x is equal to 0. What is the value for f of x? At x is equal to 0, what is the value for f of x? When x is equal to 0, what is the value for f of x? It is x square by 2. Right? So let us put f of 0 is equal to 0 square by 2, which is equal to 0 by 2 is always 0. Now no need of getting limit x tends to 0 minus, because you have to check the continuity when x greater than 0. Because in this case you have to check the continuity when x greater than 0 but not x less than 0. Okay. So in this case we can write for right hand limit. For right hand limit, limit x tends to 0 plus, we should get only right hand limit at x is equal to 0 because it is given that x is greater than 0. Here also it is given that x is greater than 0. Okay. So limit x tends to 0, f of x. What is meant by it? X is approaching towards 0 from the right hand side, and on the right of x is equal to 0, all the values of x are greater than 0. So what is the value for f of x when x greater than 0? When x greater than 0, it is x square by 2. So limit x tends to 0 plus, what is the value for f of x? It is x square by 2. So you can put x is equal to 0 out here. So 0 square by 2, which is equal to 0. So both these are equal out here. So in this case, no need of getting the value for limit x tends to 0 minus, because we have to check the continuity when x greater than 0 or is equal to 0. Okay. So both these are equal. So we have checked the continuity at x is equal to 0 out here. So it is continuous. Okay. Now let us check the continuity at x is equal to 1. So for x is equal to 1. So on the right of x is equal to 1, on the left of x is equal to 1, and at x is equal to 1, you have to check the continuity of the function f of x at x is equal to 1. Okay. Now write down for right hand limit, how will you write it? Limit x tends to 1 plus f of x is equal to limit x tends to 1 plus. Here also, what is the meaning of x tends to 1 plus? X is approaching towards 1 from the right hand side, and on the right of x is equal to 1, all the values of x are greater than 1. So what is the value for f of x when x greater than 1? When x greater than 1, what is the value for f of x? This one, right? So it is 2x square minus 3x plus 3 by 2. Is that clear to all of you? So now we can put x is equal to 1 out here. 2 1 whole square minus 3 into 1 plus 3 by 2. So which is equal to 2 minus 3 plus 3 by 2, which is equal to 3 by 2 minus 1, which is equal to half. So we got the right hand limit at x is equal to 1, which is equal to half. Okay. Now write down for left hand limit at x is equal to 1. For left hand limit, how will you write it? Limit x tends to 1 minus f of x is equal to limit x tends to 1 minus. What is the meaning of x tends to 1 minus? X is approaching towards 1 from the left hand side, and on the left of x is equal to 1, all the values of x are less than 1. So what is the value for f of x when x less than 1? When x is less than 1, then it is x square by 2. You can write here x square by 2, which is equal to x tends to 1 minus means actually it is 1. So 1 whole square divided by 2, which is equal to half. Is that clear? So here x is equal to 0 पनि यो दुईटा इक्वल आएको छ है, भनेपछि कन्टिन्युअस भइगयो at x is equal to 0 पनि. and on the right of x is equal to 0, it is continuous. Okay. Now next you have to find out the value for f of x when x exactly equal to 1. So at x is equal to 1, so what is the value for f of x? What is the value for f of x? What is the value for f of x at x is equal to 1? At x is equal to 1, what is the value for f of x? When x is equal to 1, f of x is this one, right? So 2x square minus 3x plus 3 by 2. So you put x is equal to 1, f of 1 is equal to 2, 1 whole square minus 3 into 1 plus this is your 3 by 2, or f of 1 is equal, this is your 2 minus 3 plus 3 by 2, or f of 1 is equal to 3 by 2 minus 1. So what is f of 1 is equal to, this is also half. Is that clear? That means this right hand limit is equal to left hand limit is equal to the value of the function when x exactly equal to 1. That means the function f of x is continuous at x is equal to 1 also, right? So here you can write since limit x tends to 1 plus f of x is equal to limit x tends to 1 minus f of x is equal to f of 1, right? Is equal to what? This is your f of 1. Therefore the function f of x is continuous. The function f of x is continuous at x is equal to 1. So we have proved this one also. So in the first step also you write down that since right hand limit at x is equal to 0, that is you should write there, you write it yourself. Before this for x is equal to 1 continuity, before that you write since limit x tends to 0 plus f of x is equal to f of 0. So the function f of x is continuous at x is equal to 0. You write down that one. Okay. So here we have done the second step. Now the third step is you have to check the continuity at x is equal to 2 also. But you cannot check the continuity when x greater than 2 in this case. Okay. Because we have to check the continuity in between 0 and 2 only. So right here for x is equal to 2. Right. So for not right hand limit, you cannot check right hand limit out here. You have to check the left hand limit. So for left hand limit at x is equal to 2, how will you write it? Limit x tends to 2 minus f of x, which is equal to limit x tends to 2 minus. 2 minus means x is less than 2. You know that, isn't it? When x is less than 2, what is the value for f of x? This one. So it is 2x square minus 3x plus 3 by 2. Right? So you put x is equal to 2. So let us put x is equal to out here. 2 into 2 whole square minus 3 into 2 plus 3 by 2, which is equal to 2 square is 4 2s are 8 minus 6 plus 3 by 2. 8 minus 6 is 2 plus 3 by 2, which is equal to 7 by 2. So we have got the left hand limit at x is equal to, which is equal to 7 by 2. So in this case you cannot find out the right hand limit at x is equal to, because x is greater than 2 is not given out here. So just you have to check the continuity at every point in the interval in between 0 and 2 only. So no need of getting the right hand limit out here. Okay. Now at x exactly equal to 2, this is your left hand limit. That is when x is approaching towards 2 from the left hand side. Okay. Now at x is equal to 2. Now at x is equal to 2. Therefore, when x exactly equal to 2, what is the value for f of x? When x exactly equal to 2, what is the value for f of x? Is equal to sign is out here. The value for f of x is this one. That is 2x square minus 3x plus 3 by 2. So you put x is equal to f of 2 is equal to 2 into 2 whole square minus 3 into 2 plus this is your 3 by 2, right? So write down in the next step now. So therefore f of 2 is equal to 2 whole square is 4 2s are 8, then minus 6 plus 3 by 2, or f of 2 is equal to 8 minus 6 is 2 plus 3 by 2, or f of 2 is equal to, this is your 4 by 3, right? So what did we see out here? Oh sorry, this is 7 by 2. This is 2 2s are 4 plus 3, that is 7 by 2. In this case also both these are equal, that is left hand limit at x is equal to 2 is equal to f of 2. So since limit x tends to 2 minus, since limit x tends to 2 minus f of x is equal to f of 2, therefore the function f of x is continuous at x is equal to 2. In the beginning also you have to write down, that is I did not write out there the function f of x is continuous at x is equal to 0, so you write it there, okay? त जुन चाहिँ अगाडि हामीले एउटा छोडेको थियो त्यहाँ त्यो चाहिँ तिमीहरु आफै लेख्नु, that is we have found out the right hand limit at x is equal to 0 and the value of the function at x is equal to 0. So you write down there, since limit x tends to 0 plus f of x is equal to f of 0, therefore the function f of x is continuous at x is equal to 0. So तिमीले आफै लेख्नु त्यो चाहिँ बुझ्यौ छैन? अनि सबै यो सेम भइगयो। त यहाँसम्म लेखिसकेपछि, that is just now we proved that the function f of x is continuous at x is equal to 0. The function f of x is continuous at x is equal to 1 also. The function f of x is continuous at x is equal to 2 also. Hence, the function f of x is continuous in the interval 0 less than or equal to x less than or equal to 2. So write down. So in the last step, you write down, hence the function f of x is continuous in the interval, is continuous in the interval 0 less than or equal to x less than or equal to 2. So I think you have understood it. Okay, so you can copy it. So this much is for today. So in the next class, we'll do questions from the book and from the HS question paper. Okay, so you can practice it at home.